But there are other hints that we have about what's going to be down here. We know the stinking protocol, right? If you know your users are sitting over there submitting HTTP requests, Tomcat is going to say, well, heck, I just got an HTTP request. I'm going to launch your code, okay? So when you're down here looking at the entry code, look for your protocol. Look for Tomcat classes that have to do with HTTP or HTTPS. If you're doing JMS, you need to be looking for JMS stuff, right? Okay? So we have pages of complicated stuff that make my eyes bulge and I get scared. But we know a lot more, okay? We're not completely ignorant. We know these 3 landmarks pretty well. So dig in there and find them, okay? So here's a description of what mTDp actually is and what we're going to be doing. I want you to take 4 dumps, right? So you're going to jstack, PID, press enter. Do that 4 different times, just a few seconds apart. Space them apart, doesn't really matter, okay? This is important. If you do this on an idle system, none of your code's going to be there, right? Unless you have a scheduler or something. So don't be surprised if you don't see anything, right? You have to have a loaded system. And of course, that's what our production systems are about. And that's why the second section of my book is completely devoted to load testing, right? How do you apply realistic looking load to a test environment? How many threads of load do you apply? So when you configure a load generator, you're going to say, okay, we want to fire 3 or 16 or 200 threads. We want that many threads to be firing network traffic at your application. Well, what's the magic number? What do you dial in? So the second section of my book helps you discover all that stuff for a test environment. And then I mentioned you need a few seconds in between. So bang, you've got load running, production load. And of course you can double check just by looking at the CPU. If you're not sure, right, maybe if it's an idle time, just look at the CPU. If you've got moderate level CPU, 30% or 50%, yeah, something's probably running. You probably got load, okay? So you've got load running. You've got your job up. You take 4 thread dumps with a few seconds between each. And then, here's where the analysis part comes in. If something that you can fix shows up in one of these dumps, and you see that in 2 or more threads, these threads that are under load, okay, that's worth fixing. That is going to buy you a performance gain. So again, if you see the same thing show up twice, just twice, that's something that's going to buy you improvement. So obviously, or I hope it's obvious, the more times you see threads in your dumps that have a particular method, you know, a particular trigger and, current and trigger and entry. So if you find something that has the same 3 landmarks, if you find that thing in there twice, 3 times, and you're like, oh my gosh, that doesn't need to be happening. That's somebody accidentally is invoking that, or you know, that's secondary, that's not really important, and you can comment it out, get rid of it. Okay? And again, just to repeat, the more you see something, the more it's problematic from a performance perspective. So it's pretty directly proportional. And we'll do a demo of this here in just a little bit. So this is my pathetic artwork on what these 4 thread dumps look like. So each column, right, is a thread dump. Okay, so when I was talking about, gosh, you're looking at a page of text from one request, this is that page of text right here, just one of these guys. Okay, so here's the entry, here's the trigger, there's the current. Okay? So in my testing, in the sample app I'm going to share with you, I have 3 threads of load, okay? So I configure my load generator, which is JMeter, with 3 threads. And all 3 of those firing traffic repeatedly, nonstop. No wait time, no anything. Just going send a request, the server processes it, gets the response, and immediately ships another off, okay? So my smiley faces here, my silly little smiley faces, are my code, okay? So when you get into the thread dump I mentioned, it's not going to be all your stuff, right? You're going to see lots of other people's stuff that you don't recognize, and it is a little off-putting, right? So it's a little bit, oh my gosh, what's that doing? But working with this technique for the last few years, I know it's my code. It's my code that's being loaded, so it's really my problem, right? It's my code. And a very surprising thing that I found is that when I applied 3 threads of load with no think time, I thought there might be some gaps, right? I thought, well, maybe I'll see if I've got 3 threads that are constantly pummeling the system, that, okay, maybe I'll see 1 thread on a server. Maybe I'll see 2. You know what I found? Just repeatedly, it was 3, 3, 3, 3, 3 all the time. And my environment is a little contrived, I will state that. I'm load generating from the exact same machine where the Java server is installed. I'm using Spring Boot with Tomcat. So I have JMeter on my laptop, and I have Tomcat on my laptop. And when I have JMeter, 3 threads with JMeter, bang, all 3 of those threads. This is like 90% of the time, okay? For the other 10% of the time, it like whittles down to 2. You know, rarely ever do I see just 1 thread with that configuration, okay? So here's some tips on how this all works. I've said this before. Focus on the threads under load. Assume that your code is the problem. You have to go with that mindset. It's just so easy to blank out and say, nope, I don't recognize that packet space, but that's someone else's packet space, so eh. But you know what? So often, the trigger points to, so this is a real common scenario. The trigger is pointing to a current, and the current is someone else's code. Maybe it's a library that I've used. What did you say, 75 jars that you have in your system?
Oh, yeah, more than that.
Okay. Yeah, we do too. We got time. So many times you have your trigger pointing to some a current that's in someone else's jar, right? It's going to be in your live folder, something that you're using. The first human inclination is to say, what a crappy library. Those people are really screwed up. And sometimes they did. But sometimes it's the idiom that you use to call that library. And how do you find that? Exactly with this technique. This is exactly what you need to figure it out. Okay? Okay, your package name, right? You need to check for your package name. Again, focus on all stack traces with your protocol. If there's HTTP requests coming in, check it out. Okay, so we're still on extra hints on mTDp. When you're in WebSphere, your threads are going to have a name. And that's what the name looks like. Web container, a colon, and then there's a number after it. Okay? If you're in Spring Boot Tomcat, it's going to look like this. Da, 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 da. I don't expect you to know this or memorize it. But what you can do is you can get familiar enough with your own stack traces so that you recognize what your names look like. So that when you're poking around in there, mine, not mine, right? You're going to know. Get familiar with the names of your threads. These are your babies. These threads are your children. And the stack trace presents you their status. Tells you what your kids are doing. I'm checking up on you. What are you running right now? What's your current? Okay? Common ways to mess up in this technique. You make a judgment based on just one thread dump. Okay? So generally, thread dumps show you just the things that are slow. It's crazy that so many samples can provide such a realistic picture of what's going on. I have those mathematical explanations that I showed earlier that show why this is possible. I've personally been using this technique for years with a lot of success. But you need more than one, and generally I use 4. That's what I do. So if I see something that just shows up once, I go look at the other ones. If I don't see it again, I wash my hands of it, and just say, I'm looking at something else. That's how that works. Okay? So another, and I've mentioned this already, but I just want to repeat this because it's real important. You're going to mess up if you make judgments on a system that has low load or no load. Okay? But this is, of course, is a problem using any profiling tool, right? If you have some traffic that only shows up on Thursdays and you grab that data from Thursday and it never shows up again, it's not going to look too good. But it's not because it's a thread zone, because a profiler or any other tool would have that exact same problem, right? So know your workload. Look at the CPU, make sure it's humming before you go in there and start having a look at things. Okay, again, don't lose focus of which threads are under load. Talked about this. This is real important too. Red dumps don't show garbage collection and heap problems. There's a technical explanation to that I'm not going to go into. But you know what? There are a lot of garbage collection and heap problems, and memory leaks, all kinds of stuff going on. And that is out of scope for what we're talking about tonight. Okay? So, again, I'm a plug it in now kind of guy. I want my data. I really do. I want it now. And traditional techniques for grabbing garbage collection data, they stink. You got to add parameters. You got to restart it. You got to collect a data file and then run it through a tool that'll provide you a graph. Ugh! I'm going to die before I get the data and figure out whether there's a problem or not. It's horrible. But there's a way around it. JSTAT. J-S-T-A-T. Is that included here? Yeah, there it is. That is a plug-it-in-now way to look at your garbage collection health. Again, you pass it a PID, and you get nice data. It's in